is equal to 0.529 n squared by z. And I told you that if you remember this, it is more than enough. Where what is z? Z is the atomic number. Atomic number, atomic number means it is like 1, 2, 3, 4 and so on. That is the number of electrons, which is equal to, now it is equal to the number of electrons. Okay, so which is equal to the number of protons. Yeah, then we said, Bohr said that an electron revolves around the nucleus in a fixed circular orbits. When we said what is the meaning of the word fixed, when I say what is the meaning of the word fixed, we said it is fixed in terms of radius and it is fixed in terms of energy. Radius we found out, now we need to work about the energy. Yeah, so let's move on from here. Let me just check if there is any question. Yeah, which of the following group is the highest oxidation number? Yeah, group 17. In 96, yes. All marks above 70 is very good. The others have to improve. Okay. So let's work with energy. So I said energy, total energy is equal to potential energy plus kinetic energy. Kinetic energy, you know, is half mv square, and potential energy I was telling you is equal to minus k z e square by r. Yeah. Further, I told you that mv square by r is equal to k z e square by r square. We have done. These two get cancelled and I will get this is equal to, so half kmv square will become half. So half k z e squared by r minus k z e square by r. So that is equal to minus k z e squared by 2r. So what is this minus k z e squared by 2r? This is the total energy of the electron. Okay, total energy of the electron. Yeah. Now you first make a note. I know what kind of questions you are asking. I will answer all your questions. First you reach here. Then you know r is equal to n square h square by 4 pi squared k z e square m. You can make that substitution. And you can say total energy is equal to minus k z e squared by 2 times n square h square into 4 pi square k z e square m. So this 2 will get cancelled here and it will become 2. So the total energy is equal to, you don't have to remember these formulas, don't worry, minus 2 pi square k square z square e power 4 m by n square h square. Okay, so this is the total energy. Please reach here. Okay, there is nothing to understand. I will explain to you everything. I have not explained anything so far. I will explain you everything. So I have said total energy is equal to kinetic energy plus potential energy. Then I have told you kinetic energy is this much. How I got it? I substituted. I got this. Again, in the last class, I did R is equal to this much. I substituted. There's nothing else to understand here. You please do it on your own. You please do it in your notebook. Assume what I've done is wrong. Yeah, there is nothing to explain here. That's what I'm trying to tell you. One by 2 came back here. Here, 1 by 2 came back here. 1 by 2. He's gone into the class.
He's having some trouble logging in. I mean, like he got in. There's a network issue. There's some different less network, less connection wherever he is loading. But he's in the right place.
Okay, so if you reach here, after that we will proceed from here. Yes, I will also simplify the formula further. So you don't have to remember all these. Like I said, this is the last chapter in physics in your 12th. That time you will have to remember. Please work on this and reach the last. We will simplify that last step further. Okay, so if it is done, then I will proceed. There is nothing to explain in the last step. In the last class, I have substituted for R. Please substitute for R. Now that is minimum that I am expecting you will do. Here I have got the value for R. So please substitute this value. You please substitute here and then take whatever is in the denominator to the numerator. That value, that much work you have to do. Yeah. I'm waiting. I'm waiting. First slide. This is the first slide. Hello. Ramesh there. Yeah. Can you ask Srinath if he knows? So here I wrote, yeah. Advertise எப்படி போணும் தெரியுமா? அது கேட்கலப்பா, தெரியுமா தெரியாதா அதான் கேக்குறேன். போன் பண்ணி ரமேஷ்க்கு எனக்கு போன் பண்ண சொல்லுங்க உடனே. Okay, so this is max that I could wait. So total energy is equal to kinetic energy plus potential energy. Yeah, so total energy is kinetic energy plus potential energy. Kinetic energy is equal to half mv square, which is equal to half k z e squared by r. Potential energy is equal to minus k z e squared by r. So total energy is equal to minus 1 by 2 k z e squared by r. R is equal to n square h squared by 4 pi squared k z e squared m. So substitute. So you will get total energy is equal to minus 1 by 2 k z e squared by n square h square into 4 pi squared k z e square m. So this 2 and this 2 will get cancelled. So this is equal to minus 2 pi square, k into k is k square, z into z, z square e power 4 m by n square h square. Yeah. Now this is equal to minus 2 pi square k square e power 4 m by h square into z squared by n squared. So this is the final formula that we will have to remember. Okay, we don't have to remember any of these things. Just remember that energy is proportional to minus z squared by n square. Energy is proportional to minus z squared by n squared. So if energy is proportional to minus z squared by n squared, you may make a note that energy is equal to minus 13.6 z squared by n squared. So this is in units electron volt. And remember that 1 electron volt is equal to 1.6 into 10 power minus 19. So you can write this in joules also. So if you write it in joules, it will be 13 minus 13.6 into 1.6 into 10 power minus 19 z squared by n squared joules. Okay, so please write this down, multiply this and write this as a number. So 136 into 16, 96 carry over 9, 16 3 is 48, 48 plus 9 is like 57, 5, 16, so 2, 1. So approximately it is equal to 2.18 into 10 power minus 18 into z squared by n squared joules. Yeah, so please, this you have to remember, this you have to remember, this you have to remember. This is easy to remember. So from here I have told you how each of these has come. Hey, previous slide, I don't know, I don't understand you guys many times. I think you guys start writing after I tell you to start writing. This is what I have written in the previous slide also. So there is nothing more in this. This is the only new statement here. So energy is proportional to minus z squared by n squared. Okay. Yeah, so Vignesh, I hope it is done. Students should not write fastly, but you start working on it. There's nothing to write in this. It's only to work. Anyway, reach here. Please reach here. Please multiply those two numbers and then work. Yeah, I'll wait for 2 minutes. Okay, here with the previous slide itself, I'll wait for 2 minutes. The formula is energy of an electron in an orbit. I don't understand. Is it not 2.18? Yeah. You multiply better. I don't know. I'm not. Yeah, then what else did I write? I wrote 2.18 only. Is that not? Yeah, I mean, I don't know. Is there any way? Yeah, minus all those things you please put. This is my notebook. Please don't copy from here. Minus sign is there. So minus will be there. These numbers and then be ready. Then we'll move on. One drop of contains how many milliliters of H2O, sir? I don't know. No minus sign in electron volt. क्या हुआ? Okay, so if this is done, then there is no negative because 1 electron volt is equal to this much, 1.6 into 10 power minus 19 joules. So let me explain to you. So what I am now trying to tell you is that the energy of an electron in any orbit is given by E is equal to minus 13.6 into Z squared by N squared. Okay, what does this mean? First thing is negative total energy. Negative total energy. What does the negative total energy mean? Negative total energy means that the electron is bound to the system. In this case, the nucleus. That means the electron cannot escape and cannot go out. It has to be within it is bound by the nucleus. The earth is bound by the sun. So the earth cannot move out of the solar system. The same way, the electron is bound to the system. In this case, it is bound to the nucleus. Whenever any object has a negative total energy, it means that it is bound. So we have a negative total energy. Every object on the earth has negative total energy. When it has negative total energy, it is bound. If from the earth you are launching a spacecraft which is going into Mars, you are increasing its energy till it becomes positive. Once it becomes positive, it will leave the earth and then it will go wherever you want it to go, it will go. So that is the meaning of negative total energy. Okay. Then in orbit number 1, in the K shell of hydrogen, because Z is equal to 1, N is equal to 1, energy is equal to minus 13.6 electron volt. Okay, so if you look at a hydrogen atom, this is a hydrogen atom, this is the nucleus, and hydrogen has only one electron. It will be rotating in the K shell, so its energy is minus 13.6 electron volt. Yeah, and it is in the nucleus. Now if you supply it with an energy equal to 13.6 electron volt, then this electron will escape. It will not be there with hydrogen anymore. So if you want to remove this electron from hydrogen atom, you have to supply so much of energy for one atom. Yeah, if you have 1 mole of atoms, you have 6.023 into 10 power 23. You have to supply so much of, so there are so many molecules, so many atoms, into 10 power minus 19. Okay, so many joules of energy has to be supplied if you want to ionize hydrogen. Then you can multiply this and then you can find out. So it will be 6.023 into 13.6 into 1.6 into 10 power 4 joules. Okay, so much of energy has to be supplied if you want to ionize hydrogen. Yeah, ionize means what? Remove the outermost electron. It is only one orbit, so it is the outermost electron. Yeah, this is referred to an electron. In case of hydrogen, electron in the first orbit is called the ground state. Ground state, if an electron is to be in the first shell and it is in the first shell, it is called the ground state. Okay, so in case of helium, if both the electrons are in the first shell, they are referred to as the ground state. So here the only new thing that I have told you is one, how do you ionize, and then I have also told you the meaning of the word ground state. Ground state refers to the actual state in which an electron should be in. I don't know, despite me showing you the slides for 15-20 minutes also, I don't know why we are not able to make notes. I don't understand what is the problem. Okay, I'm showing you for 4 minutes, I'm showing you each slide. So if I write the same thing 5 times, again you will ask me to show each one of them five times. I mean, I don't know. Our minds are not here. That's what I can say. Okay, anyway, energy of an electron in any orbit is given by this. This is the same thing that I wrote in the previous slide. Here, I wrote the same thing in the previous slide, and I wrote that same thing again in the previous slide. So this is the 4th time I am writing, and 4th time we are waiting for so much time. Okay, the only new statement is this circled statement here, saying that the electron is bound to the system. In this case, the system is nucleus. Yeah, and then I am saying that in the K shell, K shell means N is equal to 1, and for hydrogen means Z is equal to 1. If N is equal to 1, Z is equal to 1, this will become minus 13.6. That is the only thing that I have said. I don't know why we are taking so much time for this. Anyway, so further I am saying that if N is equal to 1, K is equal to 1 is the ground state, because there is only one electron. That one electron is in the first orbit. That is called the ground state of the electron. Ground state refers to the actual state in which an electron should be in. If it is in that state, it is called the ground state. If not, it is called the excited state. What it means is this, that suppose in hydrogen you have one electron. That one electron is in the K shell. But it is possible for you to provide energy to the electron so that the electron jumps to the second shell. Even though hydrogen does not need a second shell, the second shell, the concept of shell is nothing but energy. Okay, so in the ground state, the energy is minus 13.6 electron volt. In the second shell, it will become minus 13.6 by n square. N squared is 4, so it will become minus 13.6 by 4. So 4 will go 3 times 12, 3.4. So minus 3.4 EV. Okay, so if you supply 10.2 electron volts of energy to this hydrogen electron jumps and goes to the second shell. This is what Bohr said, that as long as it rotates in a given shell, it neither gains nor loses energy. Now, if you supply energy, an electron can jump from the first shell to the second shell. How much energy should you supply? A fixed amount of energy, 10.2 electron volt. Okay, so if you supply 10.2 electron volt, an electron will jump from the first shell to the second shell. We are talking only of hydrogen. For hydrogen, Z is equal to 1, so I don't bother about anything else. Okay, like this, please use this formula minus 13.6 by n squared and find out the energy of the K shell, that is N is equal to 1, L shell, that is N is equal to 2, M shell, that is N is equal to 3, KLM, then N shell where N is equal to 4, and O shell where N is equal to 5, OP shell where N is equal to 6. Please find out the energy of an electron in each of these. Yeah, so for the K shell, we have already found out. For the L shell, we have found out. For the M shell, it will be minus 13.6 divided by 9. For the N shell, it will be minus 13.6 divided by 16. The next minus 13.6 divided by 25, and so on. Yeah, so please find out. Yeah, I'll be back in a minute. Yeah, so these are only for hydrogen. Right now we are talking only of hydrogen. How is 3.4 enough? 3.4 is the final energy. That's what I'm trying to say. Please focus. This is the energy in the nth shell. This is not the required energy. Energy is in the nth shell. So that energy is minus 13.4. So initial energy is minus 13.6 in the K shell. Now it has gone to L shell, and L shell final is this much. So minus 13.6, you gave some energy so that it became minus 3.4. So how much energy did you give? When you take it to that side, it will become plus 13.6. So you gave 13.6 minus 3.4. So that is 10.2. Okay, please understand that. Yeah, from the ground state, its energy is minus 13.6. Now you gave some energy so that it went to the second shell. Second shell is basically energy is minus 3.4. So each of these values is not the energy that you are giving. Each of these values is the final energy in the particular shell. Okay, so all that I'm trying to say is that in hydrogen, if this is the nucleus, there is the first shell, there is the second shell, there is a third shell, and there can be infinite number of shells. Okay, so this is K, this is L, this is M, this is N. I ask you to draw up to O, P, and so on. So now in the K shell energy is equal to minus 13.6 electron volt. KL shell, it is minus 3.4 electron volt. KL M shell you will find out, and then we will write down. Okay, please find out the M shell and then N shell and so on. So the next one, M shell is minus 1.5 electron volt. Then the next one, 0.85 electron volt. O shell, minus 0.54 electron volt. Minus 0.37 electron volt. OP and so on. So if you have a calculator, it is very simple. That's what I have, so I can work it out very fast. You guys are expected to, you can't remember these values, so you should know how to calculate these values. Okay. Now what Bohr said is that an electron jumps to higher energy levels by absorbing energy. Okay, not just that, even before that, he said that each orbit has a fixed energy. How much is that fixed energy? Minus 13.6 Z squared by N squared. Yeah, so we are slowly now getting what it is. Now, because he was able to tell energy, people accepted his postulate as to why it is not releasing. So it is one step closer to the actual thing. So an electron jumps to higher energy levels by absorbing energy. How much energy? E final minus E initial. This is equal to the energy absorbed. Energy absorbed is equal to E final minus E initial. Okay, so make a note of this. Before that, I hope you have understood this. So ground state, then this. So this is the ground state. This is the ground state. L shell is the first excited state. This is the second excited state. This is the third excited state. This is the fourth excited state. This is the fifth excited state. So in case of a hydrogen, the electron is to be found in the first shell. If it is not in the first shell, but it is in the first, second, third, fourth, fifth shell, then We will say it is in the fourth excited state. Fourth excited state. So the electron is in the fourth excited state. Okay. So these numbers, we should know how to calculate. So here are 2 points. Let me come back. What is the 10th or shell more than that called? We don't need them. Sir, EV keeps on decreasing as we keep on increasing the shells. Why, sir? Because they are negative values. So it is not decreasing. Actually, it is increasing because they are negative values. Energy is higher in the outer shells. Yes. Energy is higher in the outer shells. Energy, yeah. Why they ever get, will they ever get positive? No, because the moment it is positive, the electron will escape. The moment it is greater than 0, it will escape. So that is what is called as ionization. So if you have H plus, how did you get H plus? Hydrogen got ionized. How did it get ionized? You gave the electron energy. How much energy did you give? Minus 13.6 electron volt per atom. Then it got ionized. Okay, is more for inner shells. What is this FOA? I don't understand. To make an electron jump to the next shell, we have to give energy. Exactly. Yeah, force of attraction is more in the inner shells, right? Yes, force of attraction is more. That is why the energy is less negative. I'm sorry, more negative. What is this H? H is different from H plus. Obviously, H means it has no charge. H plus means it is hydrogen without an electron. H is only for hydrogen. Atomic hydrogen is H. H plus is what? H plus is charged hydrogen. If we supply, then the electron jumps to the next shell. Correct. Correct. Yeah. So some understanding is coming right now. Okay, good. So they will never get positive because if they have to get positive, they will escape. Now let's move on. So I am saying that look, if you have an electron, the energy in the nth shell is equal to minus 13.6 into 1.6 into 10 power minus 19 joules into z squared by n squared. Yeah. So we multiplied these numbers. I forgot the value that we got, 2.18. So I go there here to the last slide, and I write energy is equal to minus 2.18 into 10 power minus 18 z squared by n squared joule. Now suppose an electron has jumped from n1 to n2. So what is the final energy? Minus 2.18 into 10 power minus 18 into z squared by n2. What is the initial energy? Minus 2.18 into 10 power minus 18 into z squared by n1. Okay, this minus will become plus. So ultimately it will become 2.18 into 10 power minus 18 z squared into 1 by n1 squared minus 1 by n2 squared. So much energy is supplied. If an electron is jumping, from n1 to n2. Okay, now the same thing I have put it as a formula. It is impossible to remember these formulas. Okay, it is impossible to remember these formulas. The only possibility is to learn how to work it out. Yeah, to learn how to work it out. So much energy is required, where n1 is the first shell, n2 is the second shell. So electron can jump from 1 to 2, it can jump from 2 to 3, it can jump from 3 to 2, it can jump from 1 to 3 directly without going to 2. It is just like you climbing stairs. So when you are going downstairs, you can come 1 stair, you can come 2 stairs, you can come 3 stairs also. You can come 1 stair and then you can go 3 stairs. So all these are possible. Okay, these electrons are not disciplined that they will just go one step after the other step. No, I can jump directly from 1 to 3. I can jump from 1 to 2 and then go from 2 to 3. I can jump directly from 1 to 4, or I can go 1 to 2 and then 2 to 4, or I can go 1 to 3 and then 3 to 4. All these are possible. Okay, all these are possible. You are talking about, you can't talk about one. We are now talking about one atom. But in reality, you cannot talk about one atom. You can only talk about even very small. 1 gram of hydrogen is how much? 6.023 into 10 power 23 atoms. Okay, so that is why we have learnt mole concept, so that we understand this concept of how many are we talking of. So even if you just talk about 1 gram, we are talking about so many atoms. So if we can talk about 1 millionth of a gram, even then we will be talking about 10 power 17 atoms. So all these things can be happening. Okay, so if you have made notes, I'll be back in a minute. Yeah, so the absorbing energy will always be positive. Exactly. You can take money. If you are taking money from me, it will always be positive. You can't take minus 20 rupees from me. But theoretically, you can say, I will give you 20 rupees. Yeah, is Earth, Mars and Neptune have same? I don't understand what do you mean by same energy. But if you mean similar concept, yes, similar concept. That is why the Earth is with the Sun. As long as the energy of the Earth is negative, it will be with the Sun. Moon's energy with respect to the Earth is negative. That's why the Moon is with the Earth. Okay, so I hope we are able to understand this. If you understand this, I will move on. I will move on. Okay, now, okay, so now what happened is you have the nucleus here. So you have given an this is the ground state, this is the nth excited state. There are so many orbits in between. An electron has jumped from here to here. How did it jump from lower to higher? It jumped from lower to higher by absorbing energy. By absorbing energy. Okay. Now the same way an electron can jump from higher to lower. An electron can jump from higher orbit to lower orbit. Okay, in this case it releases electrons. In this case it releases energy. In this case it releases energy, and the energy released is always as electromagnetic radiations. Energy released is always as electromagnetic radiations. Yeah, so just as it absorbs energy to go from lower to higher, when it comes back it releases that energy, same amount of energy. It releases the same amount of energy, and that same amount of energy is always released in the form of electromagnetic radiations, that is light. Okay, now we get all the light from the sun primarily because of electrons jumping from one orbit to another. Okay, we get all the light from sun. Whether the energy applied decides whether the electrons jump from, yes, obviously, yes. So depending on how much energy you give, it will decide whether it will jump to 1 to 2 or 1 to 3 or 1 to 4 and so on. Sir, in case of hydrogen, if we supply plus, then it jumps to L shell. No. If we supply 13.6, it will go out. If you supply 10.2, it will go to L shell. If we supply 10.2, it goes to L shell. Then it jumps to, okay. Now whether the energy applied decides. Okay, the formula I will show you. How much time? Oh, this is an instantaneous. This is, and that is another concept which Bohr said. So it is an instantaneous action. This jumping from one to another is an instantaneous action, is an instantaneous, instantaneous, instantaneous action. Okay, in fact 1 second, how much is 1 second is also defined by number of radiations released. So they say it is an atomic clock. So in Geneva there is an atomic clock, and that atomic clock releases so many radiations in 1 second. So that is what is called as 1 second. Okay, so in 1 second also it is not, it is much lesser than a nanosecond. It is nanosecond, much lesser than nanosecond. Okay, so that is what we need to understand. Okay, so first you understand this. Once you understand this, then we go here. So first you understand this. Okay, so if you get it, then you have this. Then let me go to your questions and answer. Sir, at last, can you show all the slides? I will show. How much time it takes, I explain to you. So if we supply not enough energy, yeah, then it won't get stuck in between, it won't go, it won't interact. Okay, so the very good points you guys are asking, those are all the points which Bohr has said. If you supply, so minimum energy required for an electron in case of hydrogen is 10.2 electron volt. Okay, so what if you give less than 10.2, there is no interaction. Okay, this is one of the points which Einstein made. So he got his Nobel Prize primarily because of all these things. Prior to this, people said, oh, I'm sorry, 1 minute. Power off in my place. Released energy, Tambi, if you give money, what will it be? I hope you are able to see my screen. Yeah, so what if you give less than 10.2 energy, then it will just be, there will be no interaction. So I was telling you, this is one of the points made by Einstein. So that is why he got his Nobel Prize. See, okay, we will explain, don't worry. If we supply not enough energy for a shell, then electron will get stuck in between. No, there is no interaction. Electrons are always jumping. Yes, if you keep supplying energy, they are always jumping. Electrons are so small. Your tube light works on this principle. You supply energy and the electrons are jumping. That's why it gives light. Released energy will always be positive. Okay, screen is not visible. Negative. No, yes, sir. Okay, okay. So I hope you guys are able to understand. Yeah. The atom size also increases. Yes. Sun is providing energy due to these jumping of electrons. Not only sun, every source of energy is providing us energy only because of jumping of electrons. So when you heat a metal, the metal gets hot. So what do you mean by the metal gets hot? Same thing, the electrons are jumping. Now, K shell electrons don't jump to the nucleus. They can in certain cases. If they jump into the nucleus, they release huge amounts of energy. So we won't read that now. We will read that when we do nuclear reactions. So right now we have not gone to the nucleus. Nucleus you will go only in your 12th standard. We are talking only about atomic structure. So we will talk only about jumping from one to another outside. Inside jumping releases even more energy. So that is what happens in nuclear reactions. Okay, jumping, if electron jumping to other shell, it won't affect atom. No, it doesn't affect the atom. See, all these are happening in 10 power minus 16 seconds. So there is no time for any reaction. Okay, so yeah, okay. So I think I am done for today. I'll quickly show you my slides, and then I hope my slides are visible first. And if they are visible, I hope they are visible. Can somebody put some message? Yes, no? Yes, okay, good. So here it is. So this is the first slide. This is the second slide. Okay, we had a much fruitful discussion today. This is the third slide. This is the fourth slide. I'm maybe too fast, but I showed you these for 10 minutes. This is the fifth slide. This is the sixth slide. This is the seventh slide. Now each different scientists have contributed to all these. Okay, so it was very difficult for them to collate all those things. In those days, you didn't have mobile phones that you just call up somebody, and then there was no internet also. So it's very difficult for them to find out what has happened, how it has happened, and all that. But there are at least 10 scientists who have contributed to whatever we have read today. This is Planck's contribution. So Max Planck was in Germany. So he contributed from Germany. Now these guys were all in Copenhagen. Okay. So let me just check if if electrons are jumped from one shell to the another, they will change in configuration number. No, nothing of that sort. 1 and 8. Learn about atoms by understanding, sir, why we need to learn about atoms, so that you will tell, if somebody tells you that sun is releasing light, why is sun releasing light? How can you create something which will release light? So mankind made incandescent bulbs, no, only after knowing all these things. Before that, Edison was using resistor. Lot of heat was getting generated. So now after that, they came with tube lights where a gas was being heated. So all your roadside powerful lights are there. They are all based on this principle of electrons jumping from one to another. Then again, all your semiconductors, all is based on electrons jumping from one to another. So all of semiconductors is based on this. Which group? 17th group. Second slide, sir. 11th slide. Second 11. Here, slide 1. Slide 2. Slide 3. Slide 4. Slide 11. The fact that there is no interaction, this was the contribution of Einstein. He was in Switzerland. So different people have contributed. Okay, 11. Then slide 8. Okay. So now the atomic structure, how many times, Dhanush? How many explain about a journey to? Sir, we are now doing which chapter? How many more? And explain about a journey of chemistry, please. Okay, I will explain. Kindly, ionization, something becoming an ion is called an ionization. When a element loses an electron, it's called ionization. Is some constant that we use in formula for energy of electrons. Yes. Best book, NCRT book is the best book. Then you go for Arihant publications, GRB publications. They are also reasonably good. Thank you. Thank you. Thank you. See you again tomorrow. Bye.